Welcome to the Super Memory for Schools program. My name is THUmonsic. Today we will continue with the cotangent function, the second session of the unit, trigonometric functions. The definition of the cotangent function, the notation y equals cotangent x is determined by the formula y equals cotangent x and equals the result of cosine x divided by sine x. Please take notice that the last letter of cotangent notation is T, and of the cosine notation is S. Please do not misread this. When written, it ends with the cotangent T, but it is pronounced cotangent X. And because the cotangent function is determined by the formula, the denominator must be a non-zero number. This means that the value of sine X is different from 0. Then X is different from k pi, such that k is an element of z. Overall, the domain of the cotangent function is D equals R, excluding the k pi set, where k is an element of z. Please remember this condition to solve math problems of finding the domain of a function containing cotangent values. The next part is the variation and graph of the function y equals cotangent x. Let me remind you of the domain of this function. D equals R, excluding the k pi set, where k is an element of z. This is an odd function. First, this is a symmetric domain. For example, let k equals 1. Then we get pi as the result. When k equals -1, the result is negative pi. Therefore, both pi and negative pi belong to this set. Then you all can see that this is a symmetric set. R is the result of a symmetric set minus a symmetric set. Thus, D is a symmetric set. Next, we consider f of negative x. In this case, f of x is a cotangent function. Hence, this equals cotangent of negative x. Following the rule of the opposite angles, which you have learned, it equals negative cotangent x and equals negative f of x. As a result, it is an odd function. At this point, we can conclude that among the four functions y equals sine x, y equals cosine x, y equals tangent x, and y equals cotangent x, only the function y equals cosine x is an even function. The three remaining functions are odd functions. Next, the period of cotangent function is the same as the period of tangent function. That is, it is equal to pi. Since both the cotangent of alpha plus pi and the cotangent of alpha plus k times pi equals the cotangent of alpha. Its repeated period is pi. Its value range is not limited, like the value range of tangent function, and equals R. Hence, for these types of cotangent function questions, T here will be no problem of finding the maximum and minimum values. Next, let's move on to the graph section. This is how the graph of cotangent function looks like. For this graph segment, x values are between 0 and pi, since the function's domain is R excluding the k pi set. Thus, x is invalid if it equals to 0 and pi. We use the parentheses, so I only have x values between 0 and pi to analyze this function. Please notice the 0 and pi vertical lines. The graph does not intersect these lines. It is invalid at those points. It is a downward curve, so you can see that this cotangent function is monotonically decreasing on the interval of 0 pi. And the length of this interval between 0 to pi is exactly pi. Meanwhile, the period of this function is pi. Hence, you only need to draw this curve repeatedly for the next corresponding intervals. Then you will have the entire graph on its domain D. You and I just have covered the cotangent function's definition, variation, and graph on the domain D. Now let's apply this knowledge to solve some problems. First problem, find the domain of the function. Y equals cotangent x plus pi over 4 plus sine 4x. In this case, the sine function's domain is R, so you don't need any further conditions. But for the cotangent function, I want to remind you again, sine and cosine functions don't need conditions, but tangent and cotangent do. Hence, in this situation, any angle of cotangent functions must be different from k pi. X plus pi over 4 is different from k pi. K is an element of z, which means x is different from. Move this to the right side, change the signs. Then it will be negative pi over 4 plus k pi, where k is an element of z. K is an integer. Hence, this is the condition. Its domain will be D equals r excluding the negative pi over 4 plus k pi set. Remember to put the condition k is an element of z in the curly braces. You just learned how to find a cotangent function domain. Let me remind you once again, please set the conditions for all cotangent and tangent functions in any cases. Let's move on to the last question type for today. Analyze the parity of a function containing cotangent and sine functions. Let's pay attention to this. The cotangent function is 2 times x plus pi, and the period is pi. Therefore, you can eliminate this. Before solving this problem, you need to transform the function a little bit. Y equals fx equals sine x. Copy it down, cotangent 2x plus pi. Eliminate an integer number times of pi in the angle of the tangent and cotangent functions. You will get a cotangent of 2 times x. Eliminate this pi to set the conditions more easily. Copy down the number 1. Then you only have to focus on cotangent 2x to set the condition, meaning that 2x must be different from k pi. 2 times x is different from k times pi, meaning x is different from k times pi over 2. K is an element of z. This is the function's domain. From this domain, you can see that this is a symmetric set. I will give you an example. When k equals 1, this value in the set is pi over 2. When k equals negative 1, the value is negative pi over 2. These are the two opposite numbers, so this is a symmetric set. R is a symmetric set. We have a symmetric set minus a symmetric set. So D is a symmetric set. Continue with function f of negative x. Replace x by negative x. Sine of negative x, cotangent of negative 2x plus 1. Sine of negative x equals negative sine x. Cotangent of negative 2x equals negative cotangent of 2 times x plus 1. Pay attention to this. If the number 1 wasn't here, this would equal negative f of x. This would equal negative fx. However, because there is the number 1, it doesn't equal f of x. It is different from the original function. This and this function are different. It is also different from the negative fx function. Therefore, this is neither an odd or even number. Let's review the steps in order to solve this problem. First, find the domain. Second is determine whether the domain is a symmetric set or not. If it is a symmetric set, just continue solving. If not, you can immediately conclude that the function is neither odd nor even. To continue with the symmetric case, analyze f of negative x and compare the result with f of x and negative f of x. Regarding its definition, it is defined by the formula cotangent x equals cosine x divided by sine x. Its domain D equals r excluding the k pi set, where k is an element of z. Its period is pi. It is an odd function and its range is r. This is how it looks on its graph on the domain. In today's lecture, when studying tangent and cotangent functions, you learned that there are a lot of similarities between these two functions. First is the parity, second is the cycle, and third is the ranges. The difference between them is the conditions or the domains. These are two different domains. However, there is still the similarity that you need to set conditions for both tangent, cotangent functions. The graphs are split and discontinuous since some values are excluded in the domains. This is all for the lecture. Thank you all for your attention. See you in the other lectures from the Super Memory for Schools program.